Hello. Good evening, everyone. Welcome to the third day of this FTP, Sustainable Manufacturing and Advanced Automation in Industries. So, welcome, sir. So, thank you for accepting our invitation.
Good evening. Thank you, madam. Good evening. Thank you.
So, it's our great pleasure to welcome you. So, I am honored to introduce Dr. BIJAYANANDA PATNAIK, Associate Professor in the Department of Electronics and Telecommunication Engineering at the National Institute of Technology, NIT Raipur. With 17 years of experience, Dr. Patnaik has been a dedicated educator and researcher in optical communication and digital communication systems. Dr. Patnaik has been serving as an associate professor at NIT Raipur since October 31, 2022. Before this, he spent around 11 years at the International Institute of Information Technology, IIIT Bhubaneswar, contributing significantly to academia and research. His dedication to advancing knowledge in fiber optics and non-linear optics has been widely recognized. A prolific researcher, Dr. Patnaik has authored and co-authored more than 50 research papers published in prestigious international journals and conferences. Hailing from Gunpur, Rayagada, Odisha, Dr. Patnaik pursued his PhD from the Indian Institute of Technology, Bhubaneswar in 2013. His academic excellence was recognized with the prestigious MHRD Fellowship from 2009 to 2011. With over 15 years of teaching and research experience, he continues to inspire students and contribute to the development of optical communication technology. Dr. Patnaik's expertise in free space optics, fiber optic communication, and digital communication has immense relevance in today's rapidly evolving worlds of telecommunication and information technology. His research is instrumental in advancing the field of optical wireless communication and high-speed data transmission, making modern communication systems more efficient and reliable. We are truly honored to have such a distinguished scholar and innovator with us today. Without further delay, please join me in welcoming Dr. Bijayananda Patnaik. Sir, welcome to the session.
Thank you, madam, for this nice introduction. So, good
Welcome,
evening
sir.
to all of you. As well as it's my pleasure that in front of very good all, I think all this is FDP in front of all PhD scholars FDP. I am going to present something about this the communication perspective, how it will be useful for our sustainable manufacturing. Which, maybe you can tell about the innovations, automations, how communication will be useful. That I want to highlight today. So anybody, what I feel, anybody is having any doubts, any problems, anything else, kindly interrupt me. There is no issue at all. So no doubt at the end we will be having question answer session. But in between, anybody is having any questions, queries, please feel free to ask to me. Thank you. I would like to again thanks to this IGIT entire organizing team, management, and everybody for inviting me for this talk. I'm sharing my screen. So my screen is visible, I think. Am I right? Hello, is it audible? Madam, my screen is visible. Screen is visible as well as voice is
Yes,
audible clearly. Okay, nice,
yes,
nice.
correct. Beautiful and audible, sir. You
Yes,
can proceed.
thank you. Please, thank you. So already I told you the ultra high speed communication, how a speed or high speed communication is usually useful for sustainable manufacturing and automation process that I want to highlight today. And what is an ultra high speed? You see, at present, what we are using the 4G or 5G network, which is very much useful in our communication purpose in day-to-day life, and how it is useful to the society as well as the industry also. That we will be checking and going through it in detail. So here in this case, what I mean to say, ultra high speed means you have to understand that basically in simple, the data rate of the communication is very high. No doubt what you are using in 4G maximum of 200 Mbps or in 5G, it has been claimed that 500 to 1 Gbps data rate is going on. But what it is the requirement in the future for having the sustainable manufacturing as well as automation process is a very high speed data, which is in the range of minimum of Gbps. So that is why what we are thinking is how we can achieve it. That is what our question. And what are the challenges for it and how we can overcome those challenges so that we can get a very good automation system. That is what my highlight or what I want to highlight today in my talk. So the outline of my talk will be like this: the introduction, key technology for sustainable manufacturing, communication engineering, and how it is good for or useful for sustainable manufacturing, ultra high speed communication, what are the challenges and mitigation techniques for achieving this automation process. Then I will show you some of the simulation results as well as discussion what we are doing in our research work at NIT Raipur or what we have done till now, as well as IoT, which is playing a major role for sustainable manufacturing. About that also I want to highlight. Then about some case studies, conclusion, future scope, and references. So if you go for the introduction of sustainable manufacturing, so what is sustainable manufacturing? Any manufacturing techniques which will provide or which will give an optimization as well as enhance the manufacturing process, as well as which should integrate with the data analysis, automation, green technology. Now everybody is talking about green. Green means you can tell which is energy efficient, which should consume low power. As well as if at all the power is used, that power should be from renewable energy sources. Because in future, everybody knows that everybody knows all the systems are being automated as well as the systems are IoT devices. So if at all you will go such kind of automation manufacturing process, it use very huge amount of power. But how to get those huge amount of data, amount of power? Because getting power without any sustainable technology may be a challenge in future. So that is a green technology plays an important role for as well as high speed connectivity for the smart. You know nowadays with the sustainable smart manufacturing plays also an equal role. What is smart? Any manufacturing techniques basically which uses maybe our neural network or AI ML technique, basically called our smart manufacturing technique. And how to achieve that with the help of high speed high speed communication device or high speed communication technology that we will define or we will discuss here. And if you will define what is sustainable manufacturing in simple, there are 4 points. One is called our data-driven decisions, which I told you that the all the decisions should be real time as well. It should be based on the data, real time data, how it is being captured. And next is robotics as well as automation, which everybody knows. If robot will be there in our industries, then how the work will be automated as well as smooth. You can easily understand, as well as connectivity and integration, how you have to integrate the industry requirements, industry, the appliances, industry, the different process with seamless data exchange. Now you can know that the communication is not between man and man to man. Rather than communication is also required between man to machine as well machine to machine communication. And machine to machine communication means you can able to easily understand how much fast the data or the communication speed or how much fast the data rate is. If the data rate is not that much faster, machine to machine communication cannot be done in a well required manner. So that is why connectivity and its integration with the product it plays a major role. Similarly, green technology already I told you, which is energy efficient, should be from renewable energy sources as well as adaptability. If tomorrow you want to integrate something, it should be adapted very easily. Then only we can or the technology will be accepted in the present scenario. And key technologies driving the sustainable manufacturing process is already well known to. I think you might have listened since so many lectures since last 2 days. Also, you will be listening about the IoT devices. Any device which is connected with internet for providing the necessary facility is called our IoT devices. Then artificial intelligence, already I told you, for smart manufacturing as well as for achieving a good real-time communication, definitely we need smart, intelligent systems so that the machine or the device itself can take the decision as well as can also provide the necessary requirement. Ultra high speed communication, already I told ultra high means it is here this the data rate is very high, which is in the range of Gbps. You have to understand it is in the range of what we are getting the 4G, 5G communication rather than what we are expecting in 6G and 7G. That is also the requirement in future. Similar data analysis and big data, which flows real-time data, has to be captured as well as it should be processed and time to time in a real-time basis, the decision has to be taken. That is what the key technologies for the sustainable manufacturing process. Then what are the benefits of sustainable manufacturing? Well known to you, which will produce or which will enhance our productivity, improve the quality, consistency, definitely the quality of the product, if at all it is monitored in real-time way, in an intelligent process or in a, you can tell, smart way, definitely the quality as well as consistency will increase. Then reduce the cost as well as waste. Nowadays, e-waste management is also an important challenge in the present scenario because no doubt the technology is well developed, but what it is being wasted, how it will be properly used. So that is why if at all you will follow the sustainable technology, definitely the waste will be less, and by using the waste management technique, we can also, you can tell, we can manage the waste product well. Then case studies, if you see the smart manufacturing process, time to time who have been adopted, there are certain companies which I have highlighted like Siemens, GE, Aviation and Tesla. And the industry which is linked with it is automation and manufacturing, aerospace and automotive. And they have already shown that because of this sustainable manufacturing as well as smart manufacturing, they are getting very good benefits, which I have shown in the earlier slide, like increasing the productivity, quality, as well as quantity, everything. And sustainable manufacturing implementation provides digital twins. I think all of you might have listened about the recent techniques about digital twins, where we can have the replica of the same industry at a larger distance. And by going through that replica, the engineers, the researchers, they can also tune the entire process so that the process outcome will be very better. As well as IoT enabled jet engines, which has been GE Aviation has done, as well as Tesla's AI powered quality control, which has been used and for automobile assembles, and because of which data driven optimization, and because of this technique, the, the productivity as well as quality has been achieved in a better way. Communication engineering, how communication plays a major role in sustainable manufacturing. So you know that basically in a day, in simple you can tell, if you don't have the mobile in a particular day, then you know the entire day has gone or it is said to be completely dark. So that is why communication plays a major role in almost all fields, not only in the case of manufacturing, rather than taking all policies, decisions, government, society, public at a large, communication plays a major role. So that is how reliably we can able to get a high speed communication in real time. That is what an important thing. That is why you can tell integration of the communication device with the industry plays a major role for sustainable manufacturing. And you can tell the communication plays like real-time monitoring, remote control, data-driven optimization, collaborative robotics, all these things we can able to achieve because of this, you can tell, high-speed communication device. And emerging communication techniques for industry 4.0, if you will see that how the communication techniques plays a major role, like what we are expecting in future, the 6G technology, which provides high speed, ultra high speed. It is not high speed, rather than ultra in the sense in the terms of Gbps, in the range of 10 Gbps, 20 Gbps, 40 Gbps. Now also, whenever we are going for fiber optics, we are having 100 Gbps of data rate, which is being communicated through a single fiber. Similarly, IoT, which plays a major role. I think previously people were talking of IoT only. But now, how these IoT devices plays a major role in industry, that also plays a major role. So that is IIoT is also an emerging communication technique for this industry 4.0. Similarly, edge computing devices, I think all of you know what is edge computing. The computation should be done at the data, where the data is being collected, there itself, not that at the server all this processing will be done. If the processing will be done at the edge devices, means at the data where it is collected, there itself we will compute, we will go through the data, we will analyze the data, and whatever the important, you can tell, outcome from the data, if you will transmit to the server, then definitely the server will be less loaded, as well as it can also provide efficient process. So that is why edge computing plays a major role for Industry 4.0. And integrating communication systems with industrial IoT, which involves data acquisition, you know how to collect the data, then data transmission of the data from one place to another place. Nowadays, it is not that the transmission of data is going on for maybe 1 meter, 20 meter, 20 kilometer, or not 100 kilometers. Nowadays, the communication or data transmission is required thousands of kilometers, because when you are planning to transmit the data from one point of the globe to exactly opposite point of the globe, you know that what is the distance covered. And you can tell the entire communication system throughout the globe, if you will see, the backbone is only optical fiber. Basically, no doubt, lot of channels like wire communication, wireless communication, fiber optics communication, there are a lot of communications available, but if you will see the entire communication throughout the globe, 90% of the communication channels are only fiber optics. It is which has been laid under the ground, as well as through sea, through ocean, and which is being communicated from one point of the earth to the exactly opposite point of the globe also we can able to communicate. So that is your data transmission to thousands of kilometers, millions of kilometers is a challenging thing, and which should be at a faster rate in a real time, as well as with high reliability, which is an important challenge nowadays. Then data processing and analysis, how the data will be processed in real time, as well as how to analyze by using the edge computing device, which is nothing but, you can tell, simply integration of IoT with this communication device. Decision making and control, already I told you, at the data, where the data is available, there itself the decision should be made, as well as important things should only to be sent, as well as real time control should be done in industry, so that we can able to achieve a very good automation system. And if you'll see in simple, I think you might have listened a lot of things about others things. That is what I want to highlight in my talk about these communication systems, and how this communication system plays the major role for the sustainable manufacturing technique, as well as automation process. So already you can see that the what I have been presenting, which is nothing but the requirement is nowadays user demands internet anywhere and any place. Now we people want the internet of things as well as IoT, not only in our office or in our home or anything. It is not only, it should be throughout the globe. Like for an example, it should be within the building. First figure you can see, second figure is outdoor. When you are moving out of this office or out of your home, also you should have high speed internet. And when you are walking in a subway, also you should able to get the connection, as well as when you are driving, like when you are going in a in your own vehicle, maybe car, or maybe in a public vehicle like train, also you should able to get the internet, high speed internet connection, as well as subway also you should get the internet, as well high speed train, you know nowadays lot of high speed like Vande Bharat and lot of other trains are coming, where you can tell the speed of the train is around 300 kilometer per hour, which is expected in future. In those high speed train, getting high speed internet or high speed communication without any kind of interruption or without any kind of discontinuity is a great challenge. And how to gauge those things? So that is what the user demands in future, for that is in simple nothing but internet anytime and anywhere throughout the globe. Next, certain examples which provides our well-connected devices are like IoT. What is IoT? The devices surrounding to us, which are all connected with internet, are called our Internet of Things. As well as now also, we people are very much interested for autonomous driving, driverless car. If you will put the source and destination, the car should move from one place to another place without any kind of interruption. And for achieving that, you can easily imagine what should be the speed of this communication or speed of this communication device. If the speed is not properly achieved, you cannot get autonomous driving. As well as remote healthcare, like if you can tell an example, we are sitting in India, that be at a place of maybe in Odisha, Bhubaneswar, and we want a medical facility from a doctor who is sitting maybe in USA. If you want to utilize their expertise in our own country, in our own place, then you know how the communication should be properly done. Then only we can get the remote healthcare facility in our day-to-day life. As well as drone-based delivery, which like COVID time, all were very much what interested for drone-based services. Drone means which is being like in simple how delivery will be done using the help of drone. If some items is to be delivered from one place to another place, then by using a drone you can easily imagine how much internet speed is required or what should be the communication going on between the drone as well as the earth device earth or from the server station. What should be the communication speed, what should be its reliability, what should be the data rate, then only we can get in real time the drone-based delivery systems. So that is why, in simple, by looking to this example, you can easily know that in future we need whatever the data rate we are getting at present, 200 Mbps or maybe 500 Mbps is not at all sufficient. We need to move to minimum of 1 Gbps, 2 Gbps, 1 Tbps, or 100 of Tbps. Then only we will be happy. So that is why ultra high speed communication is a major requirement in future, so that we can able to get the you can tell the automation as well as the smart manufacturing or what is the as per our requirement we can get it. So if you will see the connection between 1G to 5G or 6G, what we can tell what it is going on in simple the communication. First of all, the latency should be less, which is less than 1 millisecond. If the latency will be very high, you can easily know that the data communication will not be real time. So that is why for achieving real time communication, we should have a much faster connection, because of which we should get minimum of 10 Gbps. If the data rate is 10 Gbps, then we can tell that it is a faster communication. Similarly, we have to have super connected devices like 10,000 or thousands of devices, hundreds of devices surrounding to us, all are internet connected, and all these devices should work in real time. On how much the communication speed, you can easily imagine. Similarly, higher mobility like high speed train, already I told you, where the speed of the train is expected to be 300 kilometers per hour, and how we can get the internet as well as high speed communication. That is also the requirement in future. Similarly, ultra reliable. You see, no doubt we may get a high speed connection, but if it is not reliable, then our purpose will not be solved. So that is why the requirement of reliability is 99.9999%. It is not, it is 100% ideally, but in simple you can tell it should be very much reliable. If it is not reliable, how we can get such reliable communication? That we will discuss during my presentation. But what I mean to say, the requirement is ultra high reliable what communication device. The communication should not be disconnected. For example, let I am talking something with my friend, or now I am talking with you people, all of you, and in between, if the 3 to 4 times it has been disconnected, no one will be happy to listen the talk. As well as we will be completely unhappy. So that is what the communication is going on between now. We have around 120 participants, and means around 120 people. What the communication is going on, all should be completely reliable. If multiple times it is disconnected, we will not be happy, or our purpose will not be solved. So that is why the reliability requirement is 99.999. Similarly, already I told you, the technology should be green technology or it should be energy efficient technology. Now we are what are the device we are using in our day-to-day life also. You have different devices, and if at all a device will consume less energy, then only it will be preferable, or it can be said to be as a sustainable technology for future. If it will consume very high power or high energy, it is not at all efficient. So that is why efficient energy devices or the industry where we are working, all the devices should be energy efficient. Then only we can tell that we can achieve our goal. So that is just starting from latency, high bandwidth, high speed mobility, ultra reliability, and energy efficient technology is our requirement for achieving this automation process. And in simple, as per now, the technology, no doubt, if somebody belongs to this electronics field, they may be well familiar with this terminology, but people may not be familiar. But still, I want to tell if how to tell technically that a communication is said to be good communication or ultra reliable communication or energy efficient communication. There are certain performance parameters, and the performance parameters are nothing but these are the things. You have to measure the bandwidth. If the bandwidth is very high, like ultra high speed bandwidth, in terms of Gbps, 100 Gbps, 200 Gbps, 1 Gbps, 2 Gbps, or hundreds of Gbps, then only you can tell the communication is a good communication. Similarly, it should consume low bit error rate. Means the error should be very low. If you will, what is bit error rate? If you will transmit thousands of bits, and it, at the receiver, we have to calculate how many bits are erroneous. And if the number of erroneous bits are less, as well as the number of bits whatever you are receiving are very less erroneous, then it is said to be BER is less. And as far as the data rate which is in the range of Gbps, if the BER is very high, it is not at all acceptable. So that is why BER should be as low as possible. Similarly, high SNR, signal to noise ratio. We have to compute the signal power by noise power in a particular communication system or maybe automation purpose. And if it can provide high signal power comparing to the noise power, because noise is a must in any communication device. When you will go for communication, definitely noise will be incorporated because of the channel, because of the transmitter, because of the receiver and all those. So that is why we have to compute the signal to noise ratio. If it can provide high signal to noise ratio, then only it is acceptable. Similarly, it should be power efficient. We have to calculate the power and we have to compare with the existing technology. If the technology which we will propose will consume less power comparing to the existing, then definitely it will be accepted. Otherwise, it will not be accepted. As well as provide data security. All of you know nowadays security is an important aspect. No doubt we are getting lot of facility by using high speed internet. But if it is not secure, then we will not be happy. You know, we are doing this what you can internet banking, mobile banking through your mobile, through our internet. But if it is not secure, then people will not be happy. That is why, no doubt, we are increasing the speed. At the same time, we have to also think about the security. If the security is very high, then only it will be accepted. As well as the cost nowadays, you know, the technology is said to be smart or it may be automated. Definitely, the cost should be low. If the cost is very high, people cannot afford, and it may not be acceptable by the law, public, or maybe for the use of others. So that is why the cost should also to be less. Easy to install and maintain. All of you know the installation should also to be very less, as well as it should also require very low maintenance, and it should provide 100% of the coverage throughout the globe. It should cover, as already I told you. If it will cover a portion of this, maybe it is working fine at your office, it is working fine at your home. It is not covering when you are moving in the vehicle or maybe when you are moving in a subway, you will not be happy. So that is why the coverage should also be 100%. As well as the last point, which is important, is make decision. The network, the device, the machine should have its own intelligence, and because of its own intelligence, they should able to decide themselves which is good, which is bad, and how what are the data to be communicated to the server, which data is not to be transmitted to the server. All these things should be done at a real time, like edge computing device at the data where the data is collected, there itself it should be divided. Otherwise, it will not be providing this. So that is why making decisions definitely involves the technology like AI and ML. If the device is connected with artificial intelligence or machine learning or in simple the neural network, then definitely it can take the decision at its own. So that is why these are all the requirements as well as technical terms which is to be taken as a performance parameters for having a good as well as ultra high speed communication system. And you can tell why optical communication plays. You see, already I am telling from the beginning that communication plays a major role. Then why optical communication? So you see, for any communication system, power and bandwidth plays major role. You know how much power the system requires. The system should require as low power as possible, as well as bandwidth. Like you can tell in simple, the speed of communication in real time should be very high. Storage power and bandwidth are two important resources of any communication system, especially in sixth generation wireless technology. An optical system has a major advantage that it requires very low power and provides very huge bandwidth. So that is why widely accepted. Why it requires very low power? Basically, optical communication deals with laser technology. And all the lasers, I think those who are working in industry as well as in academics, they know laser works very low power in the range of milliwatt. If you go for RF antennas and all those which requires kilowatt and megawatt of power, but laser works in milliwatt. So that is why because the optical systems uses lasers, we require very low power, which is in the range of milliwatt. dBm, I think might have been dBm milliwatt power we requiring, as well as very huge bandwidth. Basically, the bandwidth of the optical fiber is around hundreds of terahertz. And because of these hundreds of terahertz, definitely if the bandwidth is very high, the speed of the communication will be very high. So that is why you can tell millions of dollars are being spent put web light wave system as a result of it. We are using optical systems as a modern communication system for achieving the smart communication or smart manufacturing process, automation process. We have to use optical systems because it is providing or it is consuming less power, provides very high bandwidth. That is why any communication system, in particular, in any communication in between two devices, two machines, if part of it is not optical, basically it is not said to be a modern communication system. So that is why a modern communication system, definitely part of it should be optical. Then only it will be acceptable. Otherwise, people will not accept. So that is why optical device is very, very important because it consumes low power and provides very high bandwidth. And if you see the optical systems, people used to think that optical means always it is fiber optics, maybe which is used in the industry as well as telecommunication purpose. But it is not only optical fiber. There are also other optical communication systems, which is widely used in different industries as well as in public also. Those are also called free space optics, optical wireless communication, which is widely used for satellite devices, satellite communication, mobile satellite communication, inter-satellite optical wireless communication system, underwater communication for achieving this what you can tell underwater, what how to gather the data, how to communicate with underwater devices, hybrid optical communication system. So that is what you can tell. In simple, there are six type of optical communication systems which is available, starting from fiber optics till your hybrid optical system. What is hybrid optics? Which is nothing but the combination of fiber plus free space or free space plus underwater plus satellite. If at all, it is nothing but the addition of two or three technology, which is the requirement in nowadays in the present scenario, is called our hybrid optical communication system. And then why people are preferring hybrid optical communication? In simple, you can tell if each and every system as well as devices has its own advantage and disadvantage. So that is we are taking into the advantage and disadvantages of various technologies. Nowadays, widely utilized technology is called our hybrid technique. So that is why hybrid optical communication plays a major role for providing high bandwidth, ultra high speed communication with low power consumption. Then in simple, I have shown you a diagram where slowly I am entering to the technology part. So how it will be useful for your sustainable as well as smart manufacturing plus your automation device. So fiber optics communication, it's simple, nothing but a source to destination. If a dedicated fiber is laid and it is communicated, then it is called our fiber optics communication. Clear? It may be source and destination, or it may be you can tell two machines in an industry, or maybe two devices, whatever it may be. If a dedicated fiber is used and the communication is established, then it is said to be a fiber optics communication system. Similarly, what is free space optics? if the communication between source to destination is without fiber, but if you use a laser beam, if you use a laser beam, what I am showing here, if you use a laser beam and the communication is established between transmitter to receiver, then it is said to be a free space optical communication technique, where you can tell there is no fiber. That is what the major advantage. But the major disadvantage also disadvantages like about the atmosphere, because there is no guided medium here. What will happen? Atmosphere plays a but crucial role for distortion. So that is in free space optics, how the atmospheric disturbances, or you can turn in simple, if you will turn the technical term, that is nothing but the refractive index of the atmosphere, how it will be tuned properly during the atmospheric temperature and pressure variation for providing reliable as well as high speed communication is our requirement. So that is why free space optics means in simple one building to another building, the communication is established without using the fiber, but by using the help of laser beam. And we are using laser basically because of its advantage like low power consumption and provides very high bandwidth. Okay, I think this is clear. Then it is what a simple setup of free space optics where transmitter to receiver, the communication is established. And you know, all of us that we need nowadays all is nothing but a full duplex communication. I mean, transmission and reception should be carried out simultaneously at a particular transmitter as well as at the receiver. So that is why this is what by using two laser beams, one is maybe by using red color, another is by using green color, how a high speed communication with full duplex facility can be provided. This is an example. And anything that can be done in fiber that also can be done by using free space optics, because free space optics is nothing but again the same optical communication system, but only the thing is we are not using fiber, we are using free space in the propagation medium. And this is what example where you can see that how the free space optics place or example of which there are so many buildings let in a particular city, and how they are connected with high speed as well as more reliable and low power consumption communication device. That is what it is an example. You can see these red color lines all are nothing but free space optical communication, but this free space optics place or takes place only at a very certain distance, long, loud distance is within 1 kilometer or 2 kilometer radius only you can get the facility. Because here it is completely unguided. We are taking the help of free space. So that is why for achieving the communication throughout the globe, the backbone of the communication system is fiber optic. So that is why already I told you, no doubt throughout the globe we have the communication, but more than 90% of the communication channel are simply the fiber optics. So fiber optics plays the major backbone of the entire communication system, and which provides a data rate of how much 2.5 to 10 Gbps, which is nothing but expected data rate in our 6G, and we are getting the free space. So that is why this is also an example of all optical communication, where throughout the globe we are communicating on, we are taking the help of fiber optics, and from one building to another building we are taking the help of FSO. That is why fiber plus free space. So that is why this is an example of hybrid communication system, which is going to fulfill our purpose and what provide the necessary solution. And no doubt we are telling that fiber optics or communication system is very good, but there are certain challenges. How to mitigate those challenges, certain examples, case studies also we will discuss. But what I mean to say, certain challenges which is highlighted, like fiber nonlinearity and dispersion, how the nonlinearity of the fiber plays a major, you can tell, demerit for our, because when the signal is propagated through the fiber, because of the light interaction with the fiber material, which is nothing but a glass fiber, we should have lot of nonlinear effects is found. And this nonlinear effect should be minimized properly. If the nonlinear effect will not be minimized, then what will happen? Your SNR, signal to noise ratio, will not be good. Noise power will be high, signal power will less. So that is why what will happen? The entire information will be corrupted, and we cannot get the accurate data at the receiver. So that is why fiber nonlinearity is a major important demerit of this fiber optics communication system. As well as next is called dispersion. Dispersion means it will transmit a narrow pulse at the transmitter. At the receiver, we are getting a very wider pulse. Nowadays, what we are transmitting, all the devices are called digital devices. Digital means we are transmitting the signal in terms of pulses. If a narrow pulse is transmitted at the transmitter, and if the pulse width is increased at the receiver, then we will not be happy. Then it is said to be corrupted. So that is why fiber dispersion, which involves the what you can tell the error, which should be minimized. Then next challenge is all optical communication networks. Already I told you, because from the source to destination, whatever the communication it is provided, it should be purely all optical. If it is not optical, part of it will be electrical. Then what will happen? The data rate will be less. And if the data rate will be less, then definitely you can easily tell that it cannot provide our purpose, or it cannot be said to be a ultra high speed communication. So that is why for achieving that, the all mean from source to destination, it may be fiber, it may be free space, or it may be what inter-satellite, or a combination of either of it. But it should be a completely all optical communication. Then only we can achieve a data rate in terms of TBPS. Then intelligent fiber optic transmission system. Already I told you, the network should be intelligent enough so that what is the minimum path, what is the minimum cost, all these things can be found. Then optical neural network nodes. If at all you want to develop an intelligent system, it should have its own neural network. Then only it can be said to be an intelligent. Then implementation, improvement in optical amplification technology. No doubt we are telling we can get a bandwidth of terahertz, but whatever the amplifier you are getting nowadays, or whatever it is existing till now, all are low bandwidth. The amplifier cannot be a wideband amplifier. So it is how to develop a wideband amplifier in optical domain, which is also an important challenge for fiber optic system. Similarly, long haul fiber optics communication, long haul in the sense from one point of the globe to opposite point of the globe, how we can able to communicate with high speed as well as a reliable communication. That is what called our another challenge. And advanced modulation formats like multi-dimensional modulation. This modulation basically minimizes the dispersion as well as nonlinear effect of the fiber. But we have to think for an advanced modulation system, because of which will be minimized at a lot at a greater extent. That we have to think. Similarly, equalization basically minimizes the channel distortion. Equalizer is nothing but I think all of you know, which is inverse filter, which is used for our channel for reduction of the channel distortion. So that is equalization technique development is also an important technique for fiber optics communication system. No doubt it is well developed. No, it is in the range of megahertz, gigahertz. It has been developed, but it is not well developed in the range of terahertz. So that is how it can be developed in terms of terahertz. So that is what we have to do. That is why we can tell these are all the challenges in terahertz technique. So that in terahertz also we can able to get this communication at a greater extent. Similarly, coding technique, there are a lot of coding. I think all of you know about codings like channel coding, line coding, source coding. There are so many coding techniques are available, but still how this coding will be good enough during the terahertz communication, which is an important aspect and which should be taken care. Okay, till now anybody any doubts, you can interrupt me or you can ask also. Any doubts I'm getting? If there is no doubts, we'll proceed further. Okay, I don't think so. Any doubt? You can send the message. Otherwise, then definitely your mic will be unmute and you can able to tell also. Okay. I'm not getting any message means I'm thinking that it is going well good or good enough. Similarly, what are the challenges in free space optics? So, like fiber, free space plays a major role. We have shown a lot of examples where without using fiber cable, we can also communicate or we can also get very high terahertz, ultra high speed communication. So, where we can tell that the challenges is because of the absence of the fiber, atmospheric absorption and scattering plays a major role, which is the major you can take challenge in free space optics. Similarly, atmospheric turbulence in the sense pressure, atmospheric temperature and pressure variation, because of which how the laser beam, which is being useful for communication purpose, is being distorted, and how to avoid those distortions. That is what nothing but our atmospheric turbulence. Similarly, beam divergence, we are using laser beam, which is being used for transmission from one place to another place. And the beam should be very, very narrow. If it is not very narrow, then it cannot pinpoint to the receiver. So that is why beam divergence is also an important challenge, and because of which we are getting a pointing error. If the receiver is not well pointed on the received signal, then the SNR will not be good, as well as BER will be high. So that is why how to minimize this pointing error by using a what highly directional laser beam. That is what an important challenge. Similarly, ambient light, no doubt we are using the laser light, which is in the range of 1550 nanometer, and we have the white light surrounding to us, and white light also contains 1550 nanometer. So that is how that in the presence of the ambient light, our desired signal, this 1550 nanometer will work good enough. That is what another challenge. Similarly, what is atmospheric attenuation? Already I told you, no doubt optical fiber is good enough, free space is good enough, people are telling, but the major demerit of the optical communication or free space optics is nothing but our atmospheric attenuation. You can see here from the diagram that the atmospheric attenuation varies from 6.5 dB to 225 dB per kilometer. So whenever the weather is a completely clear weather, we are getting a what communication which is providing atmospheric attenuation of 6.5 dB per kilometer. But whenever there is some kind of a fog effect, here fog is a major demerit because each and every demerit is related with its wavelength. Basically, we are using 1550 nanometer wavelength. And if you are using 1550 nanometer, and if the cloud is there, and you can tell the fog is there, which the dimensions of the fog is completely, you can tell, matching with the dimensions of the fog. So that is why if the fog is not a dense fog, then it may go the attenuation up to 150 dB per kilometer. But if it is a dense fog, definitely the attenuation goes to 225 dB per kilometer. So that is why here you can tell in simple, if the attenuation varies from 6.5 to 225 dB, how the link failure will be calculated, how the outage probability will be calculated. So that is why this is what the major challenge. So that is why during the time of winter, how free space optical communication can be properly used. That is what our requirement. Similarly, no doubt we have shown certain challenges here, like fiber and free space. How to mitigate those challenges? What the technology it has been developed to mitigate those effects? That we will highlight certain technologies like advanced modulation. Already I told you modulation plays a crucial role for minimizing the nonlinear effect as well as dispersion of the fiber. So that is why advanced modulation, coding, diversity plays a major role for mitigating all these nonlinear or what are the demerits what we have seen. All these things can be mitigated. No doubt it is not 100% mitigated, but up to certain extent it can be mitigated. Then aperture averaging, because multi already I told you the what pointing error is a major challenge. How to minimize the pointing error is one of the technique is aperture averaging. You have to calculate the data from different apertures and you have to average. If you will use this technique, definitely the pointing error problem will be solved. Similarly, adaptive optics, the optical technology should be adaptive in nature. Time to time, its direction, its angle, its reception, everything should vary. And background noise reduction, already I told the white light, which contains all the wavelength, it should be reduced well enough so that the 1550 nanometer, which is our required wavelength, should only to be communicated and we can get a higher SNR with low BER value. So that is why another is also the method is equalization, where the channel distortion will be minimized and we can able to get. And hybrid RFFS, already I told you, every system has its advantage and disadvantage. So that is why RF, the major limitation is during the rain, and FSO, the major limitation is during winter. So that is if you use a hybrid RF FSO system, then you can tell during winter we will go for RF, as well as during raining or any day we can go for FSO. Then our purpose will be solved. That is why one of the technique to mitigate this effect is hybrid RF FSO system. Now we will go for the case study that how one of these mitigation thing, how we will minimize this what distortions, or how we'll increase the SNR by using the technique. So what is fiber nonlinearity? Here I've given a simple equation. If what is a nonlinear effects in a fiber is nothing but the refractive index is a function of the square of the electric field intensity. Because the refractive index of the fiber is square of the electric field intensity, that is why the effect is said to be a nonlinear effect. Clear? And because of this nonlinear effect, what will happen? In a fiber, if you transmit 5 signals, so many other signals will also be also to be we are getting or we are achieving. So how to minimize it? You see, I've given an equation here. M is nothing but n square into n minus 1 by 2. Means M is nothing but spurious signal generator. Spurious means undesired signal generator. Undesired signal generator. Because and n is nothing but number of input channels in a DWDM system. In a fiber optics, in a single fiber, basically we are transmitting millions and billions of transmitted television as well as video calls. So that is why if you transmit millions and billions of telephone calls from this equation, it shows that the millions will produce another millions or spurious signal or undesired signal and how to reduce it. So that is why if you transmit the signal with frequency omega I, omega j and omega k, then it is producing another signals which is omega I plus or minus omega j plus or minus omega. So that is why so many plus and minus automatic frequency will be automatically we are getting. And how to minimize it? So that is what we are putting. That is why if you will take in simple the value of n equal to 2 here, capital N equal to 2, then 2 square is equal to 4 into 1 by 2, that is by 2. Means what I mean to say, if I will transmit 2 signals from Bhubaneswar, where if at all I will be receiving the signal at Delhi, I will be getting the signal in terms of 4 signals. So if I transmit 2, another 2 undesired is created. And those 2 undesired will be suppressed well enough. Then only SNR will increase. So that is why this nonlinear effects plays a major role for or minimization plays a major role for efficient as well as good communication system. So that is why we have to minimize the spurious or undesired signals. You see, I have shown something. Here it is shown by using the simulation. Already I told you I will show you some results which is based on the simulation, where you can see very easily that we have transmitted um, 2 signals at the input of the spectrum, and the output you are getting 4 signals. Clear? Means at Bhubaneswar I have transmitted only 2 signals. Then at the receiver, let it is at Delhi, I am getting 4 signals. And no doubt the signal, you can tell power, the undesired signal power is very less here, but still it is undesired. So that is why you have to use proper filter to what? Eliminate those signals, and we have to get this signal. What I mean to say, this is what called your FWM effect. Because when I am transmitting 2 signals, I am getting 4 signals at the receiver. At the transmitter, I am transmitting 2 signals, but at the receiver, I am getting 4 signals. So that is why this is called your 4-way mixing effect. And that 4-way mixing effect should be minimized. Then only the system or the communication system will be efficient. And we can easily see now what is some setup which is useful for FWM analysis. It is a simple setup where we have a transmitter like laser which is operating on 193.1 terahertz with a frequency spacing of 100 gigahertz. And here I have used 4 channels. You can go for 2 channel, 4 channel, 8 channel, or 64 channel, anything of it. And you give to an mux simple multiplexer. And multiplexer means it is nothing but conversion of one to many. One to many. So that is why here I have given 8 inputs and we are getting all these outputs at a particular mux. So at this input, let I am transmitting the signal at Bhubaneswar, then I have to, this is what the OSA optical spectrum analyzer which is being connected at the transmitter or which is at the Bhubaneswar. And at the receiver, which is nothing but Delhi, like maybe we are connecting another OSA. And if at all you will compare these 2 optical spectrum, and you can easily, then we can analyze the 4-way mixing effect very easily. So here I have taken the distance is 50 kilometer, but you can also take 50 kilometer, 100 kilometer, thousands of kilometer also. But if at all the signal is completely distorted, if it is thousands of kilometer, definitely it will be completely distorted. So that is why basically in fiber optics communication, We have multiple repeaters at different places. Maximum with a distance of 100 kilometer, we are keeping a repeater, and we are freshly generating zeros and ones for reproducing the signal. So that is why this is what a simple setup which is useful for our FWM effect analysis. And you see, using that setup, here a simple result is shown at figure A and figure B. If you will compare, in figure A, we have completely clearly visible lines, which is nothing but transmitted at a wavelength of around 1550 nanometer. But if you will see figure B, which is at the receiver, we are getting lot of signals which is jam-packed or overlapped signals. You can see lot of signals are overlapped. So this thick lines provides that the signal power is also being what corrupted with the noise, and this is what because of this four-way mixing effect. So that is why what I mean to say, this kind of nonlinear effect which is reducing our BER or which is reducing our SNR. BER reduction is good, which is reducing our SNR as well as increases the bit error rate, which should be taken care. So that is why in simple you can tell that in a fiber optic communication system, if the spurious signals or undesired signals are overlapped with this original signal, how to mitigate it? That is what the major challenge. And you can see here whatever the spectrum signals available at the right hand side and left hand side, we can easily eliminate by using a filter. But which is again overlapped with the original signal, it is very difficult to remove it by using the filter, which will drastically reduce the SNR. So that is why it needs to be taken. It has to be taken care so that our what proper or good communication can be established. Similarly, another diagram which has been shown here. So is it audible? I think somebody has written mic is off. My mic is not off. So is it audible what I am telling? Somebody has told that mic is off, not audible. I think it is not the thing. I think
Audible,
right.
it's
Right.
audible, sir.
Okay.
Yes, sir, it's audible, sir. Audible, sir.
Okay. Thank you. Thank you. So you can see from these two spectrum, which is figure A and figure B, and figure A is better or figure B is better. From this, you can easily see that in figure A, the undesired signal power is around minus 10 dBm, but in figure B, the undesired signal is around minus 40, below minus mean around minus 50 dBm. So minus 50 noise is a very good comparing to minus 10. So that is why in simple you can tell figure B is better comparing to figure A. But how to get figure B? Where in figure B we have used the input power is minus 10 dBm, means very low power comparing to this input which is 20 dBm. So that is why in a fiber optic system, if the input power is low, like minus 10 dBm, comparing to high input power which is 20 dBm, it provides better result. But in other sense, already also you can easily know that the input power is too low, then definitely we need multiple times of repeaters, as well as if it is too low, SNR will also be very high and error will be very high. Error will also be increased. So that is why we have to find out a, you can tell, optimizer technique where the input power should not be too low as well as it should not be too high. Because of which we should able to also reduce the FWM effect as well as we should also put high SNR as well as low BER value. Similarly, this is what an analysis of figure which is shown in figure A and B, where we are using different modulations like CSRZ as well as MDRZ. You can see if you will see the last column, which is nothing but our OSNR values. In figure A, the optical signal to noise ratio is around 28, 29 or 30 dBm maximum. Whereas in figure B, the OSNR value is all are more than 30, which is around 33, 32 dBm. So that is why what you can tell there is a basically in simple 3 to 4 dBm SNR improvement in case of figure B comparing to figure A. So then you can tell that figure B how you have achieved by using the MDRZ. So that is why these are all coding techniques. So MDRZ provides better result comparing to CSRZ. So that is why what I have shown you the mitigation techniques. So if you use the two different types of coding and you can compare the OSNR, If the OS kernel is better for a particular coding rather than the old one, then definitely you can tell this provides better result comparing to other. So that is why in optical communication system or for achieving an ultra high speed communication, definitely the coding techniques should be efficient or should be good enough so that we can get very high SNR value. This is what a tabular result where by varying the input power, how you are getting the four-way mixing or undesired noise power. That has been shown here. You can see minus 10 dBm to 20 dBm. We have varied the power and we have seen that the undesired power varies from minus 59 to minus 12. Minus 59 is a good figure because the noise power should be as low as possible, which is our sideband power. So that is why here it is minus 59 is good, but minus 12 is not at all good. But if you want to get minus 59, you have to also reduce the power. And already I told you, if the power is very low at the transmitter, we do multiple repeaters multiple times. The signal is to be amplified, retransmitted, redistributed. So that is why the power should not be too high, should not be too low. Similarly, by varying the channel spacing between because in a single fiber we are communicating millions of billions of telephone calls, video calls. By varying the channel spacing, also it is observed that if the channel spacing is very high, like 200 gigahertz, then the FWM power is less comparing to the low channel spacing, which is around 25 gigahertz. But if the channel spacing is very high, again you can tell the space between the two channels are very high, then definitely we need wideband amplifiers because the bandwidth of the entire system will be very high. And now the technology is not so much developed that we can get a wideband or we can tell all pass amplifying technology. So that is why now we have to think about the technique where you can easily know that the channel spacing should not be so high and channel spacing should not be so low. Then by varying the cross-sectional area of the fiber, because already I told you the entire green communication, green technology, 90% of this thing is achieved because of this fiber. So fiber, if at all we can vary the cross-sectional area from 64 micrometers to 80 micrometers square, how it is providing the undesired or noise signal. You can easily see whenever it is 80, it is minus 41 dBm. Whenever it is 64 micrometers square, it is minus 39 dBm. So if you, because FWM is a noise signal, so that is minus 41 is better comparing to minus 39. But if it is minus 41, then the cross sectional area of the fiber is very high. And if the cross sectional area of the single mode fiber will be varied too much, then single mode will change to multi mode. And in multi mode again, there is a, you can tell absorption, distortion, nonlinear is very high. So that is why by using the single mode fiber, which we are getting a communication of thousands of kilometers, millions of kilometers, how we can able to achieve. That is also a great challenge. So that is a cross sectional area of the fiber should not be too high and should not be too low. Why it should not be too high? If it is too high, then single mode will change to multi mode. If it is too low, then definitely the undesired signal or the spurious signal or the FWM power is going to be increasing. That is to be taken care. So this is what a signal, this is what a graph which is being shown here from the simulated result or from the experimental setup, where you can see that by varying this input power x-axis and in y-axis we are getting different quality factor. What is quality factor? From the communication perspective, quality factor is nothing but mu1 minus mu0 divided by sigma 1 plus sigma 0. Sigma is variance, mu is the mean. I think all of you know about it very well. So that is why what I mean the quality factor of a system should be as high as possible. You can see here as the input power is increasing, the quality factor is increasing. But after a certain threshold value, the again if at all you are increasing the power, the quality factor is not increasing. And this is because of the non-linear effect or the FWM effect, what I have shown the earlier slides. So that is why from this diagram you can tell in simple that the input power should not be too high or should not be too low. So the ideal value or the approximately you have to go for some optimization technique by using which you should able to calculate you should able to calculate the input power value, which should not be too high or too low. And here you can also see there are different lines. One is like a blue, red, and different colors, which is nothing but concerned with MDRZ, DRZ, and CSRZ. There are three different coding techniques it is used, and out of this you can you can easily say that MDRZ provides better result comparing to DRZ and CSRZ. So that is why in simple you can tell that MDRZ is better comparing to DRZ and CSRZ. So that is why nowadays a lot of hybrid coding techniques are also available, which you can apply, and you can check if that hybrid coding technique provides better comparing to MDRZ. That will be well accepted. And if at all, how it can provide better result? For achieving that, it should have the better control upon the nonlinear effect as well as dispersion of the fiber. Similarly, what you can tell for communication system, FWM, what we have seen here, the four-way mixing effect is a function of input power, channel spacing, fiber optics. We are transmitting millions, billions of telephone calls. So that is why it is a function of channel spacing. It is also the various modulation formats, coding techniques. It is changing as well as the effective cross-section area of the fiber is also plays a major role. So that is why we have to check for each and every parameters how it is varying, and we have to use the optimization technique by using which should be good enough. And you can tell here from these results, it is clear that FWM effect can be minimized by using various techniques such as input power should be as low as possible. Already I told you, if the input power is very low, then this undesired or the spurious or the FWM effect will be less. Channel spacing should be as high as possible. Similarly, fiber cross sectional should also be as high as possible, and preferably MDRZ should be used comparing to what CSRZ technique. But each and every technique has its own limit. Already I told you that if the input power is too low from the first one, you can tell if it is too low, definitely we need multiple repeaters, multiple, you can tell times the signal should be amplified as well as the SNR will be less. So that is the input power should not be too low as well as too high. Similar channel spacing should not be too low as well as should not be too high. Similarly, cross-section area should not be too high as well as too low. If it is too high, definitely single mode will change to multi-mode where we cannot go for long distance communication. But if at all if it is too low, again it provides our undesired signal or spurious signal. Okay, this is what I meant to say about the optical systems, where which place the ultra high speed communication between between transmitter to receiver, or from one device to another device, or from one machine to another machine, and basically how it provides, what are the challenges and what are the certain mitigation techniques. That is what I have highlighted. Then we will go something about this IoT, which plays a major role nowadays for this automation process. And what is in simple, I think all of you know, but still I will go through it in brief about IoT devices. The Internet of Things refers to the Internet connection every day devices of the means each and every device surrounding to us, if at all it is connected with internet for providing our necessary requirement, then it is called our IoT or Internet of Things of devices. And what are the key components of IoT? And you see, if at all we can know about what are the key components and what are the protocols, what are the privacy and what is the requirement for this, then we can able to think how we can develop a sustainable manufacturing as well as automation process. So that is why the key components of the IoT devices are sensors and actuators. All of you know well about sensors and actuators, as well as connectivity protocols, which protocol is to be followed for providing this kind of what high speed and reliable communication. That is also a key component for the IoT, as well as data processing and how to analyze the data, and user interfaces, how the interface should be provided, the interface should be connected so that we can able to get this facility. And IoT and communication engineering, and how the communication plays a major role in IoT devices. In simple, So I have shown here there are two cases. One is smart cities, another is also industrial IoT, where you can see here from the diagram that how each and every devices are well connected. If the communication will not be there between the devices, then you cannot get the IoT facility in simple. So that is why smart city, which is using by enhancing urban infrastructure services, improving manufacturing process and supply chain management, which providing because of this IoT as well as the communication between the IoT devices. And for having this sustainable manufacturing, how IoT plays a major role. In simple, you can tell I have highlighted here 3 points, which is nothing but which improve the increased efficiency. Because if the communication will be done in real time, without any kind of interruption, without any kind of distortion, then definitely the efficiency of the system as well as device as well as what you call machines will be increased. So that is why IoT and communication plays a major role for providing this increasing the efficiency of the system. Similarly, real-time data monitoring, because if you not monitor the data in real time, then what will happen? We cannot go for the automation process. In automation, no doubt, step by step, what it is to be done, it is already being fed as in a protocol, as in computer program, or it may be done automatically. But real time, if at all it is not monitored properly, then the quality as well as efficiently may hamper. So that is why IoT and communication plays a major role for getting that real-time data monitoring. And like what I told, when you are going through a train, which is at a speed of 300 kilometer per hour, and can also provide our high-speed connection without any interruption in data, then you can easily know very well that how it is very difficult without this ultra high-speed communication facility. Similarly, enhanced decision-making facility, how the decision will be done with enhanced, how the decision will be done with enhanced facility where you can tell the IoT and communication plays a major role. IoT applications in various industries, and these are the things already known to you, like smart homes, smart cities, and healthcare sector, manufacturing, different sectors. How the IoT plays a major role. Like smart homes, all of you know IoT enable home automation features such as controlling lights, appliances, and security systems remotely. If somebody let I am going out of my home, maybe for 5 6 hours, I am there at the office, but how I can control the different devices which is there at my home from a remote place, that is what called our IoT technique for our smart home application. If at all I can able to control it from a remote place, I can able to do lot of things whichever is possible from a remote place. Similarly, smart cities nowadays, people government is thinking a lot about smart city. How every city should be, or a lot of smart cities already have been identified, and how the IoT device basically in smart cities, the smart facilities like e-waste management, or you can tell traffic control, or you can tell the security. All these things is well improved because of IoT devices only. If there are no IoT devices, we cannot go for we cannot go for optimized traffic as well as management of waste materials as well as public safety. We cannot provide. So that is why IoT plays a major role in various smart cities. Similarly, healthcare sector, if you'll see, already I told you if we have an efficient doctor, maybe at a remote place, and we have to get the facility here in a long distance, then definitely IoT devices should be there. As well as for a patient, the different what parameters of the patient, how the blood pressure, sugar, like variable healthcare trackers, tele-healthcare facilities, it can be provided with the IoT devices. That it plays an important role. Similarly, manufacturing in a smarter way, in an efficient way, as well as in an intelligent way, the IoT devices plays a major role for optimizing this process. So that is why in simple you can tell IoT applications plays a major role in various industries for providing the efficient productivity. And smart home system, if you'll see one of the case studies, then how the smart home provides the convenient as well as security, automated lighting, heating, remote monitoring through a smartphone, how it can be achieved. Already I told you by using the IoT devices. And it is not only the home, but it may be also an industry, it may be by an office or any place throughout the globe. We should able to have the what control from a remote place. And if at all you want to achieve that, you can easily imagine what should be the communication facility. Communication should be at a ultra high speed, ultra high reliable, energy efficient, as well as it should consume what you can tell very low power. Clean technology also plays a role. Similarly, regulatory considerations also, as the IoT grows, regulatory frameworks must be evolved like data privacy regulations. Privacy plays a major role, already everybody knows. If the communication will be carried out without any kind of privacy, then you cannot able to get the facility. So that is why how to get the privacy is what facility by using the IoT devices and now by using different regulatory authority that is to be taken care. Standards for device interoperability. If at all you have to communicate from one device to another device, but how the standards is to be maintained so that the communication will not be what hampered, which should not be distorted, which should not be having low SNR as well as high BA that is to be taken care. Similarly, challenges in IoT's implementation. No doubt IoT plays a major role, but it has also a lot of challenges like security concern, interoperability, ensuring devices from different manufacturing work together, how to work in a together way, in a combined way that is also to be taken care, protecting data from different devices, plays a major security issue which is to be taken care. If security and interoperability will be taken care, properly by using high speed, ultra high speed, reliable communication, then definitely you can tell that the challenges of IoT have been mitigated well enough. So that is why no doubt it is related to only IoT devices. This is also interrelated with all these communication systems which we have shown, maybe the fiber optics or free space or the internet inter-satellite communication, where the communication between one to another is being carried out with different kinds of challenges such as nonlinear effects, absorption, scattering, beam divergence, as well as pointing error, and so on, which we have already somehow discussed. And challenges in implementing the sustainable management. What are the challenges? One of these important is initial investment. No doubt we are talking a lot about sustainable as well as smart, as well as high speed connection and all those, but you should also have the industry or the sector which is going to implement it nowadays require very high initial investment. And thus investment is also a major important thing. In India, we have they are not well developed, we are a developing country. So that is why what are the device or the technology we are developing that should be of low cost. If at all it is low cost, then only it will be acceptable. So that is why initial investment is also to be taken care so that what are the devices or systems we will develop, it should be available with low cost. Similar data security and privacy already already I told you, no doubt lot of security protocols, privacy protocols is also existing, but still we are also going for different type of cyber crime, cyber FI attacks, all of you know about it. And now people are talking about quantum technology also, how quantum will be replacing the traditional technology, which is basically useful for security aspects. So that is why which plays a major role that how the data security and privacy will be improved for implementing the sustainable manufacturing process. Then integration challenges, already I told you that no doubt the devices are connected, which should have the integration among each other. If the integration could not be carried out between different technology, then we cannot get the facility. Because nowadays, what you can then in simple, very well known to you that each and every devices should be connected with internet. Not only for communication between machine human being to human being, the communication is also required for machine to machine. So that is why the integration between machine to machine with well connectivity is an important. And skill gaps, no doubt the technology will be well developed, but another challenge is how these things can be properly well used by a unskilled person. If at all it requires periodical maintenance, service, then it should be also to be taken care. That is why the technology should not be so much, means the technology maintenance should not be of that much skill based. If it is not skill based, everybody can easily what use it, because most of these public or the industries where we are getting, they may not be skilled enough in all regards. Maybe somebody is skilled in one field, they may not be skilled in all other fields. So that is why we have to develop the technology which should fulfill the skill gap also, so that the industry people will not, or the public will not face any problem whenever we are using the technology. Then future trends in automation, if you will see the basic requirement in future, we are thinking that 6G will be well integrated for faster and more reliable connections, edge computing devices like processing data closer to the source and where the data is not to be transmitted to the server always. Basically, previously when we used to develop the technology, the data was collected from different places and all the data used to send to the server for processing purpose. Then what will happen? The traffic will be very high. The communication will not be reliable. That is why now people are concentrating more on edge computing devices, so that where whatever it is highly required, those data will only be to be transmitted to the server. All the data will not be transmitted to the server. It will be there at the user end only. Then AI and machine learning, all of you know, intelligent systems, intelligent device, intelligent manufacturing techniques plays a major role in automation. So that is why for future trends in automation, AI and ML plays a major role for enhanced data analysis capability as well as also taking the decision in real-time scenario. Then the future of communication in automation, you will see there are 4 points which I have highlighted here, like collaborative robotics, cloud-based manufacturing, hyper-connected factories, and real-time decision making. You can go through it in detail. So where I in simple you can tell the communication plays a major role in automation process. If you want to go for the integration or collaboration or cloud-based manufacturing system, then definitely in real time you have to take the decision. Then definitely you should have a ultra high reliable, high speed communication for getting this automation facility, or in simple like our what autonomous driving system. The future of IoT and emerging trends like emerging already I told you, edge computing, AI, 5G networks, and blockchain technology, which is very good for our, you can tell, data security as well as privacy. The futures of smart manufacturing, which is nothing but increased automation and AI, personalized and mass customization. So these things you can go with your own. I am not going to do it in detail, but conclusion at the end, I think already I have covered more than 25 minutes. But what I mean to say, speaking is very easy, but listening is very difficult. So I do understand this. That is why I want to conclude here that what we have discussed is about the sustainable manufacturing techniques, as well as various what autonomous process, autonomous driving. In simple, we have envisioned, as well as various challenges in different areas are discussed, and crucial factors for growth of it is also discussed. Continued innovation in this direction will drive a new application. So that is why, in simple, we have discussed how the ultra high speed, reliable communication provides us sustainable manufacturing as well as automation process, which we have discussed. What are its challenges and how to mitigate. Some case studies we have discussed, as well as some maybe results to experiments how we have achieved and how it is mitigated. Certain examples which we have envisioned. So these are my references where I have shown only few key references which I have used. If anybody needs the PPT, you can talk with the organizer. You can take also, not an issue for me. So that is what the acknowledgements. So we can tell at the end the acknowledgements goes to all the contributors and researchers which are working in the field of live IoT, communication engineering, smart manufacturing, automation process. Definitely the efforts plays a major role for future innovations. Now question and answer session. So Anybody is having any questions, I will be happy to answer. Please.
Thank you, sir, for this interesting session. Now the session is open for interaction. Participants can ask questions.
Hello, sir. Good evening.
Good evening.
I am
Please.
Mayank from Guru Kangdi Vishwavidyalaya, Haridwar. And first of all, I say to thanks to you because it was a very innovative session and related to my topic deeply. My topic
Right.
is my topic of the thesis is HRM 4.0.
Participants, you can directly interact with the speakers.
Yeah, ma'am. Sir, I am audible to you.
Yes, audible. Please carry on.
So, I collaborate three variable here: HRM 4.0, Industry 4.0, and the sustainability growth. There are my two questions. The first of one is this: what specific HRM 4.0 initiatives can be implemented to foster a workforce that is not only proficient in Industry 4.0 technologies, but also actively engage in promoting sustainable practices?
Right.
My first question. And the second one is, what are the potential consequences of Industry 4.0 on sustainable development, and how can practices SRM 4.0 practices help mitigate these risks? These are my questions.
Right. Very good question. So what I mean to say, what we are getting that Industry 4.0, out of that, it involves a lot of things. Out of that, what I have highlighted is about the communication prospect. Okay, so that is why in industry, if you want to get this thing to be done in an automatic way, definitely you can tell efficiency as well as the productivity will increase. But for achieving that automatic thing to be done, we need definitely a high-speed communication facility, and as well as the device should be smart enough. And for getting that smart enough, we have to have incorporate some of the other AI and ML techniques, artificial intelligence, machine learning, deep learning. Nowadays, people are talking more about it, and how to incorporate those things so that the machine will be intelligent enough, and whenever the machine is facing any problem, how it can be mitigated automatically. That we have to think. And if it can be done, it is good enough. So for achieving that, maybe for AI, ML, or real-time data to be taken out, we should have a very good communication facility.
Hello.
And for achieving that high-speed, good communication facility, part of this communication should be optical. It may be fiber or
Hello.
free space or any laser-based communication. So that is why in Industry 4.0, this laser-based communication plays a major role for automation as well as smart manufacturing process, as well as sustainable, as well as what I told you, that technology should be green enough, it should be energy efficient, means it should consume low power. So if this system or the device is AI and ML based, it will be having its own intelligence. And if by using that intelligence devices, definitely we can improve its efficiency. And so that is why in simple, just try to incorporate AI ML techniques or intelligence in the system or the device so that it will work in a better way.
Sir,
So I think I
whenever,
answer. Yes,
whenever
please.
we're talking about these technologies like IoT, artificial intelligence, blockchain, and etc., and
Right.
HRM 4.0 always interact with the consumption of manpower during
Right.
the all the areas. But Industry 4.0 says that there is a manpower where we can utilize them, but we can consume the manpower all over the hazardous place. So
Right.
the collaboration of HRM 4.0, Industry 4.0, how can it impact the sustainability? That is my main question.
No, no, the technology is said to be sustainable. In simple, if at all it follows certain guidelines. Guidelines in the sense, it should consume low power, it should be energy efficient, it should be intelligent, it should be smart. Got it. So whatever the existing system available with us, how it will be energy efficient, that we have to think. And no doubt in a maybe in a remote area, hazardous area where it is
Yeah.
very difficult to go, how we can improve the remote communication facility. Now you can in communication, one of the major technology, LoRa technology. I think you might have listened. LoRa plays a major role in remote communication system, because wherever the people cannot go to a area or which is risky to go, people use the LoRa technology. LoRa means, you can a long range wideband network, where we can have the facility that without the involvement of human being, proper communication between machine to human being is being carried out. So that is
Yes.
why whatever the existing technique, where you have to incorporate the human being, where you can plan for this remote communication as well as high productivity with good smart techniques to be used.
Yeah. Thank you. Thanks a lot, sir. Thanks a lot, sir.
Thank you, thank you, thank
Thanks
you.
for
I think
valuable feedback. And it was a great meet to you. Thanks a lot, sir. Once
nice.
again.
Thank you a lot. Thank you.
Participants, now please switch on your videos for a photo session. Sir, please switch on your video.
Yes, sir. Yes.
Thank you, sir. All the participants are requested to switch on their videos.
Okay, I think the photo session is done. Any other queries? I will be happy to answer if anybody is having any queries. Please.
Thank you all. Thank you, sir, for this great session. And
Thank you.
meet in the next session shortly.
Okay, thank you all. Let us disperse. We will be meeting in a later time. Thank you all. You have a nice day.
Thank you, sir.
Thank you.
Thank you, sir.